For today's lesson, our focus standard comes from Grade 7, Ratios and Proportional Relationships, Standard 2, C, Represent Proportional Relationships by Equations. The topic comes from our Proportional Relationships unit, Writing Equations from Graphs and Tables. Our essential question is, how do the unit rates help us write equations for proportional relationships? Please take a moment, pausing the video if you need to copy the topic and essential question into your header, along with today's date, set the question column and your note column, and resume the video when you're ready to begin. Let's start with a couple reminders about proportional relationships. There are two requirements for a relationship to be proportional. First, it has to have a constant of proportionality, which is a fancy phrase to say unit rate. And number two is both variables have to start at 0. So, with those reminders, let's take a look at our first problem. So here we have a graph representing a relationship. Can you identify what the two variables are? What is this graph telling us? Well, the labels are the key. It's talking about the cost of erasers, and our first variable is the number of erasers purchased, and that's here what these numbers on the x-axis represent. And on the y-axis, it's labeled total cost. So our second variable is total cost. So let's examine this further. We want to know, is it proportional? So, thinking about our two requirements, does it start at 0, 0? Meaning, is when the number of erasers purchased, the x variable is 0, is the cost also 0? Well, I would say yes to that, because right here in our graph, we see the origin where x is 0 and y is 0, and the line for this relationship starts at 0, 0. So yes, it does start at 0, 0. So that's the first requirement. Does it also have a unit rate? Can we figure out what that is from the graph? Well, if we take a look here, it looks like the cost goes up to 0.5, so that must be 50 cents, and over 1, meaning 1 eraser purchased, so it goes up 50 cents for 1 eraser. Does that keep happening throughout the rest of the graph? Yeah, it sure does, and I've drawn that a few more times. So it goes up 50 cents to when 1 is purchased, up 50 more cents to $1 when we purchase 2, up to $1.50, 50 more cents when we purchase 3, up 50 cents to $2 when we purchase 4, and so on and so forth. And we could have drawn those arrows all the way through. They kind of look like stair steps, and they're all the same size. They go up the same amount each time as they go over. That's what creates this nice line. So, what do you think the unit rate is if it goes up 50 cents for every eraser that is purchased? You said 50 cents per eraser. I'd agree with you. That's our unit rate. So our question has been, how can we use our unit rate to write our equation? Well, since if I buy 5 erasers, that's $2.50. I know that I just need to multiply 5 times 50 cents, and that will give me the price for the total cost. What if I buy 10? Well, if I buy 10 erasers and multiply that by 50 cents, and I follow that over, that's $5. And that's what 10 times 50 cents is. So our equation is the total cost equals 50 cents times the number of erasers purchased. t equals 0.50n. Notice that those are our variables. The total cost, our y variable, equal to our unit rate times our x variable, n. Let's try another one. This time, we're looking at a table. And again, before we can write an equation, we have to decide, is this table proportional? So remember the questions that we asked about that. Do both the variables start at 0? Do we know what the unit rate is? If it is proportional, and we say, yes, it starts at 0, 0, and we know what the unit rate is, then we can very quickly write our equation. Before we get into that, let's identify, what is this table telling us? What are our two variables? Well, looks like we're at a package company. It's called Package Express. And it looks like we're looking at the weight in pounds of a package or a box and the price to ship it. So these are our two variables. See if you can analyze this table to decide if it's proportional. And then check back when you're ready to compare. If you said that the variables both start at 0, I'd agree, because we can see when the weight is 0 pounds, it costs $0 to ship the package. That makes sense. So can we now analyze our table to figure out what the unit rate is? It might be helpful to look to see if there's a pattern by how much the price is increasing and how much the weight is increasing. Well, what I noticed as I did my analysis on this table to determine if it had a unit rate was just like I was showing you. See if you can find a pattern. And what I noticed is that every time it was adding 7. Just as the weight, and that was the price, right? The price is adding 7 every time that the weight increases by 1. So if you have a package that is 1 pound, it'll cost you $7. If you have a package that weighs 6 pounds, well, 6 times 7 is 42. So notice how we can find that unit rate and how it might help us to write our equation. So if our unit rate is $7 per pound, what do you think our equation is? Remember, think back to what our variables are, how we can use our unit rate to put it all together as an equation. If you had an equation like this, I would agree with you. Your variables might be different, but the price that we have to pay to ship a box or a package is equal to our unit rate of 7 times the weight of the package. So price equals 7W. Again, you might have used different variables, but your setup should be the same. That's going to conclude our video for today. Please make sure that your notes are complete and that you are ready to work with more problems like this in class.